I am Oyewole Olatunbosun. I'm here to present to you a tutorial on differential calculus, particularly derivatives of power functions. Right. Now look at example 1. We have to differentiate x raised to the power 6 plus 5. How do we differentiate problem of this kind? This is a power function. Right. You can see the power of x there is 6. Now what are the steps that we need to take to differentiate functions of this nature? Let's look at them. Number 1, we need to use the odd power of x to multiply the coefficient of x. We're going to use the odd power of x to multiply the coefficient of x. Then we subtract 1 from the odd power of x to get the new power of x. That is the 2 basic steps that we really need to take when differentiating power function. Right, let's see how that applies to the example above. Now you can see now the y equals to x to the power 6 plus 5 here changes to 5x to the power 6 plus 5x raised to the power 0. The x raised to the power 0 is t1 because from indices anything raised to the power 0 is what? 1. So we now have 5, but we are writing x to the power 0 there just to make our differentiation easy. And the y, the x will be what? 6. We'll come forward here. That's 6. Then x will be 6 minus 1. That is the new power will be equal to the odd power minus 1 plus. Now you bring out the constant and you open a bracket into which we are going to put the derivative of the x raised to the power 0. So and that 0 will come here forward. Then x will be raised to the power 0 minus 1. That is subtracting 1 from the odd power. Then what do we have? 6 minus 1 is 5. So we have 6x raised to the power 5 plus everything here will be 0 because 0 times anything is 0. So we have 0 inside the bracket. That reduces this term towards 0. So we have 6x raised to the power 5 plus 0 equals to 6x raised to the power 5. Right? One fact that we really need to appreciate here is that the derivative of a constant is always what? 0 as far as calculus is concerned. And also we know that we noticed that the 6, which is the power of x, now becomes the coefficient of x. It's multiplying the coefficient here, that is 6. And also the new power of the derivative is what? Odd power minus 1. So that is 6 minus 1, which is now what? 5. And all because this is a constant, we factor it out. We now differentiated only the function, which is 0x raised to the power 0 minus 1. But this 0 has nullified everything here and they become what? 0. So we have 5 times 0 to what? 0. So that is it. The knowledge of indices is very important when considering calculus, especially in differential calculus for now. So I recommend that you go through our videos on indices and laws of indices. Right, let's move on to the next example. Right, we have to obtain the derivative of x raised to the power 3 over 2 plus 2x plus 1. Now here you can see that it's a little bit different from what we did previously. The power of x here is a fraction. Then we have a linear function and a constant. Now to differentiate that, we have to rewrite everything so that only the constant term will change towards 1x raised to the power 0. We notice that we know from the previous knowledge that the derivative of 1 would be what? 0. So without anything, we know that this is going to give us 0. Now, x to the power 3 over 2 has become this. So this power will come forward, and then x will now be 3 over 2 minus 1. That's the power of the x there. You know that the new power is equal to odd power minus 1. So that is it. Then plus these 2 here come out of the bracket. Then we'll put the derivative of x raised to the power 1. The derivative of x raised to the power 1 will be in the bracket. That's 1x raised to the power what? 1 minus 1. This one comes forward, and then 1 minus 1, that's 0. So that is x raised to the power 0 here. This 0 will nullify everything, and this turns to 0 because it's a constant. Now we have 3 over 2x raised to the power 1 over 2, because 3 over 2 minus 1 is what? 1 over 2. So we have 3 over 2x raised to the power half plus 2, because everything in this bracket has turned to what? 1. X raised to the power 0 is 1. 1 times 1 is 1. Times 2 is what? 2. So we have 2 here. So that is it. Now we have 3 over 2. Converting this one to a radical, so we have x raised to the power half is what? Root x. So 3 over 2 root x plus 2. And then that is 3 root x over 2 plus 2. From laws of indices, we have that root x is x raised to the power half. So our divided x is what? Our divided x is 3 root x over 2 plus 2. 3 root x over 2 plus 2. 3 root x over 2 plus 2. Thank you very much. I advise that you work on indices very well, because when you talk of the derivative of power functions, we really need to understand indices. Because from time to time, we use indices to solve problems that involve differential calculus, particularly power derivative of power function. I'm going to provide examples, 100 worked examples on calculus, and I want you to follow us diligently on my channel. I'm going to do my best to help you to grow in mathematical knowledge, and I thank you for staying with me. All the best.